Hi everyone. So today we're going to look at the new section, very small part, called finding the average value of a function. So this will be the last bit of work for your test next week, Wednesday. Okay, so we start off just coming up with the formula to find the average value of a function. So let's say we're given a sequence of terms. So let's say we have b is equal to the sequence b is b1, b2, b3, ... up to bn. Okay, so we've got a collection of terms b from b1 to bn, and I'll ask you, what is the average value of b? So what you would do to find the average value is sum up all of the terms and then divide by the number of terms. So that would be b1 plus b2 plus b3 all the way to bn. So you add all of them up and then you divide by the number of terms that there are, in this case n. Okay, so that would be the average value of all of these terms. Now what we want to do is extend this idea to find the average value of a function. So instead of having discrete terms like we have b1, b2, b3, we're going to have a continuous range. In other words, we're going to have something like this. So if this is x and this is f of x, then between a and b, our function might do something like this. Something like that. And what we want to do is find some function, a constant function, that is the average of this function over the interval. Yeah, so how do we go about doing that? Well, we're going to use the same idea as before. So we're going to try to find the sum of the function over the interval and then divide by how many terms there are. But in this case, it's a continuous function. So you can't add up a continuous function. So instead, what we do is we try and find this average. So let's call that this line here, f average. We try and find what this average function needs to be such that the area below this average function, that area in blue, is equal to the area below the given function. So let's put that in green. Okay, so that's the idea we're going to use to define this average function. We want the area below the average function to be equal to the area below the given function. Okay, on this interval AB. So what does this give us? This gives us that the average function, which is a constant function, times b minus a, that gives us the area because it's the height of the rectangle times the width. We want this to be equal to the area under the given function. Now we know the area under the given function is just the integral from a to b of that function. So the integral from a to b of the given function. Okay, but we still want to find this f average. So we divide by b minus a. So we get f average is equal to 1 over b minus a, the integral from a to b, f of x dx. And this gives us the formula for the average function. And we see that this is very similar to what we started off with. So this average of the b terms was the sum of the b terms divided by how many there were. Now we see in this case, we have the integral of the function divided by the width of the interval. So this is the width of the interval. We can think of this as n, like the number of terms that there are. So we don't have an exact number of terms, again, because it's continuous from a to b. but that acts as if it were the number of terms. And this is the integral of the function. And we see that the integral of the function you can think of as like the continuous extension, because it's continuous now, for the sum over R of BR. Okay, so it's a very similar formula to what we had, but since the function is continuous, the sum needs to be replaced with an integral, and the number of terms is replaced with the width of the interval. Okay, so if you make those two replacements, we get the average value formula over here. Okay, are there any questions about this? Okay, so let's take a look at a couple of examples. Okay, so example 1, we're given the function f of x is equal to 3x squared plus 8x on the interval -1 to 2. Okay, so that's what we're given. We need to find the average value of this function. So f average, which is our constant average function now, is going to be 1 over b minus a, the integral from a to b of our function. So in this case, it's going to be 1 over 2 minus 1, the integral from -1 to 2 of 3x squared plus 8x. Okay, so we could work this out. 2 minus 1 is just 2 plus 1, so it's going to be 1/3 the integral from -1 to 2 of 3x squared plus 8x dx. Again, this is very straightforward. We've done this many times now. This is going to be 1/3 of x cubed plus 4x squared from -1 to 2. Okay, so that's 1/3. If I substitute 2, 2 cubed is going to be 8. 2 squared is 4, but times 4, so that's going to be plus 16 minus, and then if I substitute -1, so -1 cubed is -1, -1 squared is just 1, okay, because we're squaring it, so times by 4, it's just going to be plus 4. Okay, so we're going to get 1/3, 8 plus 16 minus 4 plus 1. So that's 1/3 of 21. Okay, or you can write this as 21 over 3. Okay, so that's the average value of this function. Okay, so you just need to substitute everything into this formula over here, and then you'll get some constant out, and that's going to be the average value of the function. Okay, any questions so far? Okay, let's take a look at another example. Example 2. We have the function f of x is equal to x cos x on the interval 0 to pi. Yeah, something like that. So again, we want to find the average value of this function. So f average is going to be 1 over b minus a, the integral from a to b, f of x dx. Yeah, something like that. So let's substitute what we have. This is going to be 1 over b minus a, so that's going to be 1 over pi minus 0, or just 1 over pi. Then we have the integral from 0 to pi, x cos x dx. Okay, now we see that this one involves integration by parts, because we've got this function x times cos x. Okay, so we have to use integration by parts on the side. Okay, so how do we deal with that? Well, we need to let u be something we can differentiate. So that's going to be x. We need to let dv be the rest of it now. So dv is going to be cos x dx. Okay, so du will be dx. And if we integrate dv, this is going to be equal to sine x. Okay, so we've got du and we've got v. So this is now going to become 1 over pi. Okay, we're going to have u times v, and then we need to evaluate that. So that's going to be x sine x, evaluated from 0 to pi, minus the integral from 0 to pi of v du. So that's going to be sine x dx. Okay, so we've just done our integration by parts. So remember our uv term, we need to then evaluate that from 0 to pi, and then the integral of v du, remember that becomes a definite integral. Okay, so please make sure you remember that. Okay, so in this case, we're going to have 1 over pi. So we're going to have pi times the sine of pi minus 0. Okay, so that's for this first part. Okay, minus the second part, we can multiply this. So we have 1 over pi, integral from 0 to pi, sine of x dx. Okay, so this first term, we've already got 0, and we know that sine of pi is 0. So all of that just goes away. So we're left with minus 1 over pi, integral from 0 to pi, sine of x dx. Okay, so what does this give us? This gives us minus 1 over pi. The integral of sine is minus cosine from 0 to pi. So this gives us plus 1 over pi. So I can just put the minus and the minus to make a plus. Cosine of pi is minus 1. Minus cosine of 0 is 1. So this gives us minus 2 over pi. Okay, so this gives us the average value of this function here. Okay, so you see that this integral here, over here, for the average value, okay, it's not going to be a straightforward integral like we had right at the beginning. This integral here, it could have a u substitution, it could have integration by parts, or it could even have both. Okay, so maybe you have to do a u substitution first and then integration by parts, or maybe the second integral for integration by parts could have another u substitution. Okay, so it's not going to be your regular polynomial integration. It's going to be something a bit more difficult than that. Okay, so just keep that in mind when you have to go through these questions. Okay, so do you have any questions for me so far? Okay, no questions. Okay, let's take a look at another example then. Okay, example 3. So we have our function f is equal to x times the square root of 4 minus x squared on the interval 0, 2. Okay, so we have something like this. We want to find the average value. So again, f average is equal to 1 over b minus a, the integral from a to b of our function. Okay, so let's substitute what we know. So this is going to be 1 over 2 minus 0. So that's just going to become 1/2. the integral from 0 to 2, and then f of x becomes x square root 4 minus x squared. Okay, so now we see in this example that we have to do a u substitution, okay, because we've got this outer function being a square root and this inner function being 4 minus x squared. Okay, and we know that if we take the derivative of this inside part, we get minus 2x. Okay, with a bit of manipulation, we can get that to be x. Okay, so that's why we need to use a u substitution. So how do we do that? So u is equal to 4 minus x squared. Okay, that's part one. Then we need to find the differential du. So du is going to be minus 2x dx. But remember, we want to just x dx. So we take the minus 2 across. So we have minus 1/2 du is x dx. So that's step one. Step two. And remember, for definite integrals, we also need to change the bounds. So 0 and 2, those are the x bounds. So this is x equals 0 and x equals 2. We need to change that into u bounds. Okay, so if x is equal to 0, then u is equal to 4 minus 0 squared, so that's going to be 4. If x is equal to 2, then u is going to be 4 minus 2 squared, so that's 4 minus 4, that's going to be 0. Okay, and that was step 3. Okay, so we've done our u substitution there. We've done the u substitution, so u equals 4 minus x squared. We found the differential du, and we changed the bounds. So now we get a new integral, 1/2 integral. The new lower bound is 4. The new upper bound is 0. And then we have the square root of u. So we can write that as u to the 1/2. And then x dx is minus 1/2 du. Okay, so that's just our new integral now. Okay, so we can take the minus 1/2 out. So we get minus 1/4, the integral from 4 to 0, u to the 1/2 du. Okay, now just to avoid any confusion with the bounds, we see that the lower bound is bigger than the upper bound. Okay, so that doesn't really work. So we can swap the bounds, provided we multiply by minus 1. Because remember, whenever you swap the bounds, you pick up a minus sign. So this is going to be 1/4, the integral from 0 to 4 of u to the 1/2 du. Okay, so now the upper bound is bigger than the lower bound, which is what we want. Okay, so let's do the integral. So we have 1/4, add 1 to the exponent to make it 3/2. Divide by that, we get 2/3. U to the 3/2 from 0 to 4. Okay, so that's going to become 1/6, 4 to the 3/2. Okay, but 4 to the 1/2 is going to be 2. 2 to the 3 is 8. So we end up with 8/6, or we can write that as 4/3. Okay, so that gives us our average value for this function. Okay, and you see in this case, we had to do u substitution. Okay, so remember to look for all those integration techniques. So maybe it's just you use the power rule, then it's pretty easy. You might have to do u substitution. You might have to do integration by parts, or a mix of them. Okay, so whenever you're given an integral from now on, please make sure that you look for those integration techniques. Okay, so I won't be saying use u substitution for this question. Okay, I'll just give you the question and then it will be up to you. Okay, I've got a question here. Can you please re-explain number 3? Okay, no worries, I can do that. Okay, so let's just go over number 3 again. So we're given the function f of x is x square root what did we have there? 4 minus x squared. Okay, and then this was on the interval from 0 to 2. Okay, we want to find the average value of this function. So we start off with the average value formula. So f average is 1 over b minus a, the integral from a to b of our function. Okay, so this is always the formula that you write down first. Okay, that's what we're going to be using. So let's substitute what we know. B minus a is going to be 2 minus 0. So that's just going to be 2. So we have 1 over 2, the integral from 0 to 2. And then our function is x square root 4 minus x squared. Okay, so now we've got a product of two things. So whenever you have a product of two functions, you should be thinking to yourself, let me check for a u substitution first. And if that doesn't work, maybe I need to use integration by parts. So in this case, we can use a u substitution. Why? Because we can see we've got this inside function, 4 minus x squared. Okay, it's inside the square root function, so we call it the inside function. If we take the derivative of this, we get minus 2x. Okay, just quickly taking the derivative in your head. And we see that this outside part is x dx. So minus 2x is very similar to x dx. So that gives you the idea of how to do the u substitution. Okay, so that's just the thinking that you need to go through. Now we need to do it properly. So the first thing we need to do is let u be equal to the inside function. So u is equal to 4 minus x squared. This is the inside function. Okay, so now we need to find du. So du is going to be du by dx dx. So du is going to be minus 2x dx. But remember, we only wanted x dx. That's what shows up in the question. So we want this part. We don't want the minus 2. So we take this minus 2 and we put it on the other side. So we get minus 1/2 du is equal to x dx, which is what we want. Okay, that's this x dx that shows up here. Okay, so what we can do is we can replace the square root of 4 minus x squared with the square root of u. X dx can be replaced with minus 1/2 du. Okay, good. But remember, this is a definite integral, so we have the extra third step of changing the bounds. Remember, these bounds are x equals 0 to x equals 2. We need to change it to u equals something for the lower and upper bounds. So if x is equal to 0, then u is going to be 4 minus 0 squared. That's going to be 4. So we can write that as u equals 4. If x is equal to 2, then u is going to be 4 minus 2 squared. That's 4 minus 4, so u is equal to 0. So we have our new lower bound and our new upper bound. Okay. So let's make our 3 substitutions there. So this is going to be 1/2 the integral. What is our new lower bound? It's going to be 4. What is the new upper bound? It's going to be 0. Okay, the square root of 4 minus x squared becomes the square root of u. X dx becomes minus 1/2 du. Okay, so we can take the minus 1/2 outside, so we end up with minus 1/4. The integral from 4 to 0 of u to the 1/2 du. Now notice the lower bound is bigger than the upper bound. Okay, we don't really want to work with that. Okay, it gets a bit messy later on because of all the minus signs. So we want the upper bound to be bigger than the lower bound. So we swap them around, but then we pick up a minus sign, because if you swap the bounds, you get a minus sign. So the minus will then become a plus. So this becomes 1/4 plus 1/4, because the minus became a plus, the integral from 0 to 4 of u to the 1/2 du. Okay, so now we just integrate. So we have 1/4. We add 1 to the exponent to make it 3/2. Divide by that, we get 2/3, u to the 3/2, from 0 to 4. So this gives us 1/4 of 2/3. It's going to be 1/6. And then we're going to have 4 to the 3/2. Okay, but 4 to the 3/2 is just going to be 8. So we have 8/6, or we can simplify that down to 4/3. Okay, just dividing top and bottom by 2. Okay, so this gives us our average value of the function. Okay, is that all right now? Okay, awesome. Okay, any other questions about this procedure?
No, sir, but could you please explain homework problem number 2 from yesterday?
Okay, sure. Let me just get that. Okay, let's just see what that was. Homework problem number 2, okay? Okay, so this was homework number 2. Okay, so this was the integral from 0 to pi/4 of x sec squared x dx. Okay, so we need to find which of these terms is easier to differentiate and which term is easier to integrate. Now, of course, u would be very easy to differentiate because the derivative of x becomes 1. So it becomes much simpler when you differentiate. So that tells us that u needs to be equal to x and dv must be equal to everything else. Okay, so now we've got u and we've got dv. Now we need to find du and v. So du is going to be dx. And if we integrate both sides here, v is going to be the integral of sec squared. That's just going to be tan. Okay, so we've got all 4 things that we need. Now, remember, the integral from 0 to pi/4 of u dv is equal to uv from 0 to pi/4 minus the integral from 0 to pi/4 v du. That's our formula for integration by parts. So let's use that. So the integral from 0 to pi/4 of u dv is just our x sec squared x dx, which is what we started off with. This is going to be equal to u times v from 0 to pi/4. So that's going to be x tan x from 0 to pi/4 minus the integral from 0 to pi/4 of tan x dx. Okay, so now we do our substitution and our integration there. So if we substitute pi/4, we're going to get pi/4 tan of pi/4. And if we substitute 0, we're just going to get 0 times 0. That's just 0. minus the integral from 0 to pi over 4 tan x dx. Okay, now tan of pi over 4, that's just tan of 45 degrees, so that's just 1. So we end up with pi over 4 minus the integral from 0 to pi over 4 tan of x dx. Okay, now we need to figure out what this is. So let's do that on the side here. So the integral from 0 to pi over 4 of tan x dx, we can write this as the integral from 0 to pi over 4 of sine x over cosine x dx. Yeah, now we can do a u substitution. So if we let u be this bottom term, so if we say u is equal to cos x, then du is going to be minus sine x dx, which is almost what we have at the top here. But instead, we have this minus sign. So we take the minus sign to the other side. So minus du is going to be sine x dx. Okay, which is what we've got in the numerator there, sine x dx. Okay, but we also need to change the bounds. So if x is equal to 0, then we have u is equal to cos of 0, so u is equal to 1. If x is equal to pi over 4, then u is going to be cos of pi over 4, so that's going to be 1 over root 2. Okay, so after the u substitution, we have the integral from 1 to 1 over root 2. Sine x dx is minus du, and cos of x is just u. So we have minus the integral from 1 to 1 over root 2, 1 over u du. But the integral of 1 over u is just the natural log. So we end up with minus the natural log of u from 1 to 1 over root 2. So we're going to have minus the natural log of 1 over root 2 minus the natural log of 1. Okay, but the natural log of 1, that's just going to be 0. So that term we can get rid of. So we end up with minus the natural log of 1 over root 2. Okay, but we can just use our log rules to simplify this. This is going to be minus the natural log of 2 to the minus 1/2. Okay, but this exponent for the log, that can come out to the front. Okay, remember your log laws. So this is going to be minus 1 times minus 1/2, that's just 1/2, the natural log of 2. So that's as simple as we're going to get it. So this 1/2 natural log of 2 is this term over here. So the integral from 0 to pi over 4 tan x dx is 1/2 the natural log of 2. So we just substitute that inside there. So that means our final answer, the integral from 0 to pi over 4 x sec squared x dx is going to be, well, we had pi over 4 minus the integral of tan, but we said that was 1/2 log 2. So that's going to be pi over 4 minus 1/2 log 2. Yeah, and that gives us our final answer. So you see this is broken down into a number of steps. So the first part is to do integration by parts. Then we end up with this tan integral, which we can do on the side. So we do all of the side working to find the integral of tan. We substitute back, and then we get our final answer. Okay, is that all right?
Yes, thank you, sir.
Okay. I saw some people that posted solutions. They just wrote down straight what the answer was for the integral of tan. Please don't do that in the test. because all of this extra stuff here, this is all for marks as well. Okay, so you need to show all your working to get the marks. Okay, so if you just write down what the answer is, I can't give you any, extra marks for that. Because if this whole thing is out of 5 and you just put down the final answer, I can only give you 1. Okay, I need to see all your working there to give you all the marks. Okay, so if you're in doubt, please just show all your working so then I can give you those marks. Okay, any other questions? Okay, so just the final note for the test on the integrals. Remember that these integrals that you're going to get in the test, they might be very straightforward power rule integrals. It could be U substitution. It could be integration by parts, or it could be a combination of them. Okay, I'm not going to tell you what you need to do. Okay, so I'm just going to give you the integral, or you need to come up with the integral, and then you need to figure it out from there. Okay, so maybe, one of the volume questions, maybe it needs a U substitution, or the question on area between curves, maybe it needs integration by parts. Okay, so you should be comfortable figuring out which technique you need to use for the different integrals. Okay, so this U substitution and integration by parts, it will be, distributed among all the questions. Okay, so that you can spot what you need to do. Okay, and of course, you're going to be marked on whether you can spot it or not. So if I can see you understand this needs to be integration by parts, then you get your part marks for showing that. Or if I can see that it needs to be a U substitution, you're going to get your marks for that. Okay, so I'm marking based on your techniques. This final answer right at the end, that is just going to be 1 mark, right? So if you make a mistake with the minus sign, or your adding is wrong or something like that, then you only lose 1 mark at the end. You don't lose all of the other marks. Okay, so I just want to see that you can get your integration technique right. The final answer, everyone makes mistakes with adding and stuff, so that's just 1 mark. Okay, but everything else, that's the important stuff. Okay, so that's just a bit more on your test 2 that's coming up. Are there any questions about test 2? Okay, so the practice test is already up on Learn 2022, as well as the solutions and the solutions for all of the tutorials that we've done so far. Okay, so you've got everything you need. If you do need help over the weekend, please ask me or the tutors. We're happy to help. And then Monday and Tuesday, that will be for revision, okay, where we will go over the practice tests. Okay, and then you write on Wednesday, normal time. Okay, good luck with your preparations, and I'll see you on Monday. Bye, everyone.